Introducing the ADQ35 wideband digitizer, a cutting-edge solution designed for high-speed data acquisition. This advanced device is built with fourth-generation hardware and firmware, ensuring performance and reliability. With its 12-bit vertical resolution, the ADQ35 wideband provides excellent precision for all your measurements. You have the flexibility to choose between two channels operating at 5 gigasamples per second or a single channel at 10 gigasamples per second, depending on your specific application needs. Additionally, the digitizer is available in configurations of 8 and 4 gigasamples per second or 6 and 3 gigasamples per second, offering even more versatility. Experience wideband performance with AC-coupled inputs that provide up to 9 GHz of usable bandwidth and a 1.4 volt peak-to-peak input range. The ADQ35 wideband also features 8 GB onboard memory, allowing you to capture and store large amounts of data seamlessly. The ADQ35 wideband is a great choice for several high-frequency applications. With its 12-bit resolution and up to 10 gigasamples per second sampling rate, it offers high precision and accuracy. The 9 GHz analog input bandwidth makes it suitable for satellite monitoring, RFIC testing, radar, and wireless communication, ensuring reliable data capture. Its real-time signal processing and high data throughput are beneficial for LiDAR and distributed fiber optic sensing. Additionally, its flexibility and performance make it ideal for software-defined radio, allowing for efficient signal processing. Let's delve into the analog front-end features and performance of the ADQ35 wideband. This digitizer offers a 9 GHz usable analog bandwidth, making it ideal for high-frequency applications. It features an AC-coupled input with a 50 ohm impedance, ensuring compatibility with a wide range of signals. The voltage input range is 1.4 volt peak-to-peak, providing the flexibility needed for various signal amplitudes. In terms of analog performance, the ADQ35 wideband boasts a signal-to-noise ratio, SNR, of 53 decibels below carrier and a spurious free dynamic range, SFDR, of 58 decibels below carrier, ensuring high-quality signal acquisition. The ADQ35 wideband digitizer boasts an impressive usable input frequency range of 9 GHz, with a negative 3 decibel input bandwidth of approximately 7.2 GHz, ensuring high performance across a wide frequency spectrum. At 9 GHz, it exhibits only a 6.5 decibel attenuation, demonstrating excellent high-frequency response. Gain roll-off can be compensated, allowing system developers to boost gain at high frequencies. This capability helps extend the bandwidth and increase the signal-to-noise ratio, SNR, at high frequencies, optimizing performance for demanding applications. ADQ35 wideband features an open FPGA architecture, allowing users to implement custom real-time signal processing algorithms. This flexibility enables tailored solutions for specific application requirements, enhancing performance and functionality by leveraging the powerful onboard FPGA resources. At the heart of the ADQ35 wideband is the AMD Kintex Ultrascale KU115 FPGA, known for its high performance and efficiency. This FPGA offers a balance of processing power and energy efficiency, making it ideal for demanding applications such as radar, medical imaging, and satellite monitoring. The optional firmware development kit provides users with the tools needed to develop custom firmware for the ADQ35 wideband. This kit includes access to the FPGA's resources, enabling the integration of user-defined logic with the pre-installed firmware. It is based on the AMD development tool suite, requiring users to have access to these tools. Teledyne SP Devices offers several optional firmware packages that extend the functionality of the ADQ35 wideband. These packages include pre-compiled functions commonly used in various applications, allowing for real-time signal processing and data reduction directly on the FPGA. This approach helps to offload the host PC and optimize overall system performance. The FWDAQ is the default data acquisition firmware pre-installed on the ADQ35 wideband. It includes essential functions for standard operation, such as digital baseline stabilization. FWDAQ also supports various signal processing and data acquisition functions, ensuring reliable and efficient data capture. The FWPD is an optional firmware package designed for applications requiring precise pulse detection and analysis. It enhances the ADQ35 wideband capability to detect and process pulses in real time, making it suitable for applications like LiDAR and time-of-flight measurements. The FWATD firmware package equips the ADQ35 wideband with advanced tools for sophisticated time domain measurements. It includes multiple noise suppression methods, digital baseline stabilization, and waveform accumulation, which are essential for achieving high dynamic range and accurate signal detection in noisy environments. The ADQ35 wideband supports the implementation of a digital down converter, DDC, either in the FPGA or on a GPU. This flexibility allows users to choose the most suitable platform for their specific application needs, enabling efficient frequency translation and decimation of high-speed signals. The ADQ35 wideband digitizer is optimized for high-throughput applications, offering sustained streaming at 14 GB per second to both CPU and GPU. One of its key benefits is GPU peer-to-peer streaming, which allows direct data transfer to the GPU with minimal CPU involvement. This method outperforms conventional solutions that rely on copying data via the host PC's RAM. GPU peer-to-peer streaming complements the open FPGA architecture of the ADQ35 wideband, as GPUs are more suitable than FPGAs for certain applications and algorithms, providing a versatile solution for various tasks. Additionally, GPUs are more affordable and have shorter development times compared to FPGAs. GPU programming languages are also less complex than hardware description languages, HDL, making development more accessible. The ADQ35 wideband supports PCIe Generation 3 with 16 lanes, Generation 3 by 16, ensuring high-speed data transfer and connectivity. The data rate calculation is straightforward. With 2 channels at 5 gigasamples per second each and 2 bytes per sample, the total data rate reaches 20 gigabytes per second. Without compressions, samples are acquired and transferred as 2 bytes each. But with data compression, they can instead be transferred by 12, 10, or 8-bit. To enable 100% duty cycle streaming at 10 gigasamples per second, the ADQ35 wideband utilizes 10-bit data compression. In its raw form, the ADQ35 wideband achieves a data rate of 20 gigabytes per second, which exceeds the 14 gigabyte per second link capacity. However, with 12-bit compression, the data rate is reduced to 15 gigabytes per second. Using 10-bit compression, the data rate comes down to 12.5 gigabytes per second. And with 8-bit compression, it is further reduced to 10 gigabytes per second. The ADQ35 wideband digitizer is designed for seamless system-level integration, offering flexible and robust clocking and trigger features. It supports high-precision clocking with multiple sources, including both internal and external clock sources, as well as clock references. For system-level synchronization, the digitizer provides a clock reference output, and fine-tuning of the external clock reference is possible using the built-in delay line, ensuring precise timing adjustments. Additionally, the ADQ35 wideband features timestamp capabilities for accurate event logging. It supports both internal and external triggers, with a high resolution of 50 picoseconds and a rearm time of just 20 nanoseconds. The trigger can also be used as a general-purpose input-output, GPIO, adding further flexibility to your system. The ADQ35 wideband digitizer comes with a comprehensive software suite, included free of charge, supporting both Windows and Linux operating systems for flexibility in various environments. It includes examples in C, C++, Python, and more, making integration with existing workflows straightforward. The well-documented Application Programming Interface API ensures smooth and efficient development. The standalone software, Digitizer Studio, offers powerful configuration, control, and display capabilities, simplifying both performance evaluation and system-level integration. Co-developed with Teledyne LaCroix, this software suite is based on over 20 years of software development experience, ensuring reliability and robustness. Digitizer Studio offers a range of features to enhance your experience with the ADQ35 wideband digitizer. It helps you get acquainted with the underlying hardware and understand parameter interdependencies and valid settings. The software provides powerful and easy-to-use configuration capabilities for setting up individual or multiple boards. Built-in error checking ensures valid parameter settings, preventing configuration issues. You can enjoy an efficient workflow for applying settings to many digitizers simultaneously using familiar matrix-style editing. The block diagram view shows the hardware architecture and visualizes parameter interdependencies in real time. Additionally, Digitizer Studio includes powerful plotting and math functions, providing comprehensive analysis tools. We encourage you to take a look at our developed system Digitizer Studio, which streamlines hardware and system-level integration, as well as daily operations. The features and functions supported by Digitizer Studio are vast and can be read in our user guide. In the table view, users can apply board level or channel settings individually or in groups using a matrix-style interface. This makes it easy to copy and paste multiple parameter values, simplifying the setup of many devices in multi-channel systems. The diagram view shows how individual parameters relate to the hardware architecture. It also helps users explore parameter dependencies by automatically adjusting parameters in real time based on other settings. Digitizer Studio supports various functions for test and measurement tasks and performance evaluations. Users can measure performance parameters like spurious free dynamic range, SFDR, and apply mathematical functions like FFT. Results are displayed in a graph interface. For more details, you can download the user guide from our website. The digitizer includes an open FPGA, allowing for custom real-time signal processing and the integration of additional functions. Data from the ADC is processed by the FPGA, which can perform various signal processing tasks, such as filtering, averaging, and DDC. The digitizer supports multiple clocking options, including internal and external clock sources, as well as clock reference inputs and outputs for system synchronization. Its triggering capabilities include both internal and external triggers, with high precision and fast rearm times. The digitizer also features a PCIe Gen 3x16 interface, enabling high-speed data transfer to the host system. Additional components include onboard memory for data buffering and storage, as well as various input and output connectors for flexible system integration.